Okay guys, so we're going to start out with number 81. Let's see. Can we fix the projector a little bit? Just push it over to the side. Thank you. Okay, guys, listen up. So starting with 81, so Peter doesn't get angry that I put it in the wrong numerical order. This is, again, guys, this is out of chapter 4 for reference for the video. This is chapter 4, number 81 in the brown book, so chapter 4. Okay, so all of these questions we're asking about acid-base neutralization, or most of them at least. To do this, the first thing you had to do for each one of these problems was write out the actual equation that was going to happen between the acid and the base. So for A, it was asking you, we had a certain molarity of NaOH. We had 50 milliliters of it, and so I figured out how many moles of NaOH that meant we had. Then I multiplied the moles of NaOH by the mole ratio between the acid and the base to figure out how many moles of acid we would need. And once I figure out how many moles of acid I need, okay, so moles on top, liters on bottom gives me molarity, right? So if I put my moles that I need versus my x liters, this is what I'm solving for, equals the given molarity that I have to react with the base. So that's how I set it up. And then I just solved for x, which gave me the number of liters I would need for the acid. Okay? So I think this is the big trick here, this last step. If you didn't know how to do that, that might have made it a little bit difficult. Questions on A? Okay, and again, this will be posted up on YouTube even before the end of the school day, so if you guys miss any of this, you can go back and look at it. As far as B goes, here's your chemical reaction. This is why we have to write it out first, because we have certain ratios change between the acid and the base. So in this case, we're starting with grams instead of molarity of our base, right, Anthony? We have to figure out how many moles we have, so divide by molar mass to figure out how many moles of our base. Then we multiply the moles of our base times the mole ratio between the acid and the base to figure out how many moles of acid we need. And then use the same technique down here to figure out how many liters of that acid we would need. And so we get this answer here. Questions on B? No? Am I going too quickly? I see pencil still moving, so I'll wait. Alright, next up here comes C. C was a little bit different. It wasn't an acid-base reaction, it was a precipitation reaction. I see you, Sharon. No, I'll wait. I'm good? Okay. Alright, so in this case, we've got silver nitrate and potassium chloride reacting. We're making silver chloride as our solid. So the question is asking, what was it? We have 785 milligrams of potassium chloride, and it's asking how many, let's see, what molarity of AgNO3 would we need to react if we used 25.8 milliliters of it to make all of the chlorine come out. So anyway, the way you set this up, turn your milligrams into grams first. A lot of people don't remember how to do that. So 1 gram is 1,000 milligrams. Do not forget that little trick. Okay, then figure out in terms of moles of KCl that you have, because this was KCl, and now you can use your mole ratio between the two, okay? And that gets you the number of moles of silver nitrate you would need to precipitate out all of the chlorine. Okay, essentially, guys, you're figuring out, okay, I have so much of this, how much of this do I need to react with all of that to make my solid? Okay, that's what you guys are figuring out, using this ratio right here. So anyway, now that we know how many moles we need, now we can just plug it into the molarity equation. So we know how many moles we need. And the problem said, okay, if we have 25.8 milliliters of it, what's the molarity? So you just put moles over liters, and it gives you the molarity. Okay, so that's how you do C. A lot of the times these problems end up being a lot easier than you think. Okay, and you guys can already see D right down here. Here's the equation. You just start out with a given amount of liters of your acid times the molarity times the mole ratio of base to acid And then this question was asking how many grams of base needs to be dissolved to neutralize the acid, and so we have to multiply our moles by the molar mass to get to grams of base needed to be in the solution. So there you go. Are there any questions on A through D? We absolutely should be standing solid on this. Guys, it's going to come back to haunt you. Next semester is essentially all in solutions. I'm not even joking. Everything that you have to do next semester is all dealing with molarities, concentrations of ions. It's coming back to haunt you. So if you're not good at this yet, come after school, watch this video, whatever you need to do to get good at it. Okay? Yeah. The answer for B was 769 milliliters. Or 0.769 liters. Yeah. Okay. Again, if you need to recap this, watch the video. So here comes 81. Okay. 87. Okay. 87. Here it goes. So the first thing we have to figure out is how these two solutions are going to react to each other. So we're looking at nickel sulfate and potassium hydroxide. They're going to react and they're going to make nickel hydroxide solid. Okay, that was one of the questions you had to do. So the first one was writing the equation. Second one was identifying the solid using your flowchart. The next step, you had to figure out what the limiting reactant is. Guys, we should be good at this by now. You start with the given amounts of each reactant. Do you guys remember starting with the volume and multiplying by the molarity? Do you guys remember doing this at all? Yeah. Okay. So we start with the volume of KOH, multiplied by the molarity of KOH, and then we use the mole ratio between the solid and the KOH to figure out how much of the solid we're going to make. I went ahead and put that into grams because part D asks you how many grams you can make, and so I put it into grams. And then I did the same thing with the NiSO4. This is the starting volume times its molarity times the ratio between NiSO4 and the solid product, multiplied by the molar mass of the solid product to get grams of solid product. And now comparing my two answers, I get way less of my solid product if I start with KOH. That tells me then that KOH is the limiting reactant. Raise your hand if you correctly identified the limiting reactant. Very good job. Okay. So now that we know what the limiting reactant is, we can go back and say, okay, I made 0.9272 grams of my solid, so that's the answer to D. That's how much is produced. Okay, raise your hand if you got that far as well. Very good. Okay, questions so far? Okay. I want to see show of thumbs so far. Miss O, yeah, I knocked that out of the park, no problem. Miss O, I needed a little bit of refresher before I could do that part. And then Miss O, I think I slept through this chapter. Okay. All right, good. So let's look at Owen's like 1 and 3. They're awesome. Okay. Moving through. Okay. That's just so frustrating. I'm happy for you, Owen. I'm happy. Owen can sleep and ace everything. Okay. It is sad. Okay, so for E is the tricky part, and I promise you will see a question like E on the free response for the midterm. I promise you. So that's why I'm recording this and putting on YouTube, so you can rewatch how this is done. Okay? So, E was figuring out what the concentration of the ions in solution is going to be after the reaction happens. Okay? So, the first thing to logic through, guys, all of the OH was used to make the solid. I know this because KOH is my limiting reactant. Okay? KOH is my limiting reactant. The solid is NiOH2. So if my solid is NiOH2 and my limiting reactant has OH in it, that means I'm going to run out of OH, and that's going to stop my reaction, which is why I know I'm not going to have any OH floating around after the reaction is done. Okay? So I don't have to calculate the concentration of OH, but I do have to calculate the concentration of some other things. So the K plus did not go into the solid at all, so I know I absolutely have K plus floating around, along with SO42 minus. That was still floating around too. And so both of those for sure I'm going to have to calculate. And then as far as the nickel goes, some of it went into the solid because the solid was NiOH2, but it's the excess reactant, which means I'm going to have some left over, and I have to figure out what's left over of the nickel. Okay? So let's do the easy one first. Potassium, whatever we poured into this mixture is what's left. So what I did to do this, seriously the easiest way to do this is M1V1 equals M2V2. I took the molarity of the KOH times the volume of the KOH that I used initially, set it equal to the new molarity times the new volume once the two solutions had been added together. Okay, so solution 1 and 2 add together to be 300 milliliters. And that gets me my concentration of K+. Really, guys, what this would give me is the new molarity of the KOH. But because I have a 1-to-1 ratio between K and OH in the solution, I know it's the same molarity of K+ as KOH. Okay? Guys, what would I have had to do differently if it were K2OH? Like if there were two Ks? What would the molarity be? It would be doubled. Okay? So if it were, like, for instance, K2OH, then the concentration of K would then just be this number times 2. Okay, so you can still use this if it's not a 1-to-1 ratio. Just keep in mind that you have to multiply your final answer by however many moles of that ion you have in solution. Okay? So anyway, that's how you do the first one. As far as the next one goes, SO4 2- is the same idea. You take the molarity of whatever compound contained SO4 2- times the initial volume of that solution, and then X is the new molarity, 300 is the new volume, and so this is really the molarity of the NiSO4. But again, if within a NiSO4 I have 1 mole of SO4, so whatever the answer was for this, I'll have the same answer for SO4 2-. Questions there? Those were the easy parts. On to the harder one. Okay, nickel. Okay, so as far as the nickel goes, again, I'll reiterate, some of this went into the solid, and some of it's still left in solution. So if some of it is still left in solution, I have to figure out how much was used. Okay, so the first thing I'm going to do is start with my given amount of my limiting reactant. So I start with my 100 milliliters of my limiting reactant times the molarity of the limiting reactant times the reagent containing nickel over the limiting reactant. This is the ratio within the formula. Okay? What this answer gives me is how much NiSO4 was used to make the solid. Okay? Now I can go down here and figure out, okay, if I know how much was used, I have to also know how much I started with in the first place. So now I take the volume of the NiSO4 that I started with times the molarity of the NiSO4, and that gets me to the moles of NiSO4 that I started with. Okay? So now I know how much I used and how much I started with. So now I can just subtract. So I have this how much nickel I started with. Notice, guys, I'm just focusing on the Ni2+ ion, minus how much I used, and that's how much Ni2+ now remains in solution. Okay? So now that I know how much is remaining in solution in moles, I just put that over the volume, and I get my concentration of Ni2+. Raise your hand if you got that as your answer, by the way. Few people? Oh, lots of you. Okay, that's good. All right, are there any questions? Can I answer anything you might have? Sam?
So, like, what if that if it wasn't a 1-to-1 ratio?
If it weren't a 1-to-1 ratio, you would have to multiply both of these by whatever that number would be. Like if it were Ni2SO4, you would just multiply by 2. And you could even set that up in a stoichiometry problem. What you could do is continue. Let's pretend for a second it was Ni2SO4. Then you could just multiply, make one more conversion, and you would put for every 1 mole of Ni2SO4, you have 2 moles of Ni2+, and then you would get your answer in moles of Ni2+. Oh, you can't see what I'm writing, but you see what I'm saying.
For used and?
For used and for started with. Yep, you could just add this last conversion in there. Okay? All right, any other questions? All right, looking good. So guys, don't forget, I'm going to be posting this on YouTube so you guys can watch it over and over again.